Hi, let's cover some data and analytics services now. BigQuery, which is one of the premier cloud data warehouses, and we covered BigQuery in detail during the databases section. But just a kind of a brush up, it's the Google Cloud's fully managed petabyte scale and cost effective analytical data warehouse solution. And it's got built in features like machine learning, geospatial analysis, and business intelligence. In terms of how the BigQuery architecture works, is you have streaming data and the bulk load data that you can ingest into BigQuery. The BigQuery uh, is split into basically a storage layer and the compute layer. Both of these layers are connected through petabit network, and the different ways you can access BigQuery is through any of the SQL compliant tools, REST APIs, web UIs, CLIs, and a lot of client libraries in many different languages. The serverless architecture, which decouples this storage and compute, allows you to scale independently on demand. So you're not paying for compute while you are just storing the data. You pay for compute only when you are actually running a query against it. In BigQuery, the pricing is based on the amount of data that is processed. So it completely depends on how you write your queries, and those the computing units are divided into slots, and you get charged based on slots. When it comes to the storage layer, the organization of BigQuery is you have a project, you define a project, and then within a project you define data sets. So data set A, data set B. Think of data set A or any data set as a database, and then within the data set you have tables. Now all of this data is stored underneath in a file system called Colossus. That's Google's file system, and pretty much the same file system is used for all other services like cloud storage, or in fact Bigtable, Spanner, and all of those. Now, how does it look like on the UI? It's very UI friendly. You have a query editor where you write your queries, and then it displays you results. It's very it's self-service and very intuitive, and user friendly as well. Now, in terms of what are the technologies which make up BigQuery under the hood? So compute is Dremel, which is a large multi-tenant cluster that executes SQL query. Storage is, of course, Colossus. It's Google's global storage system, and BigQuery leverages the columnar storage format and compression algorithm to store data in Colossus. Compute and storage talk to each other through this petabit network, which is based on Jupyter. BigQuery is orchestrated by Borg, an open source project called Borg, which is a precursor to Kubernetes. The mixers and the slots. So the slots, as we talked about, is basically that the computing unit. They're all run by Borg, which allocates hardware resources. Now, the next interesting service is Cloud Dataprep. What is Cloud Dataprep? Cloud Dataprep, it's by a company called Trifacta, is an intelligent data service for visually exploring, cleaning, and preparing structured and unstructured data for analysis, reporting, and machine learning. So think of cloud data prep as a profiling tool. So your data comes, you can visually look at data, you can do lots of analysis, and this is really useful as part of feature engineering for machine learning use cases, because to write an effective ML model, you need to know the data, you need to identify the features that's useful for you. So similarly, collapse the data, or combine the data, or expand the data, or split the data. All of this you can do only if you understand that data. So cloud data prep is a really good tool in that case. How does it work? So you have all of the users. They access it through a standard compliant web browser. The first thing that they do is they create connection to the source of data. Some connections, such as desktop upload, are automatically created. So through like a friendly UI, they create a connection to the databases. Then through those connections, they create reference to specific data sets. Then they load the samples of that data into the user interface. Then they build sequence of steps to transform the sample data through user interface controls. The primary object that you create is called recipe. A recipe is a sequence of transformation steps that you create based on that data set. So this example, it could be tables or file storage or something. What you do is you bring in the sample data set, you create a recipe. Think of a list of transformation steps. You apply that against it, and that gives you sequential output. Then you execute that job to basically perform that sequence of steps across the entire data set. So you have done it on the sample, then you execute it across the entire data set, which yields you an output data set, and you can receive that in your preferred destination in the format that you are looking for. As needed, you can also export the result from the platform, and all of this is done on UI. So how does the UI look like? This is how the UI look like. So if you look at this UI, it's literally a profiling tool. So for each one of the columns, it's basically giving you the characteristics of its data. What is the characteristics? Is you've taken a sample, and in cloud data prep terms, these are the words which is used technically. So sampling means taking a sample of that data set. What could be the predictive transformation on that one? So for some example, extract values matching this, or it starts with this, or it starts with this, replace 0 with this. So a lot of times you get data, you need to apply replace null value with 0, or replace null value with this. And sometimes if it is a date field, if it is at 11:59 or something, do it 12. Or if it is float values, if it is more than 0.5, you take the next number. So those kind of predictive transformation, it gives you out of the box. Then the visual profiling rapid target. So after you apply this transformation, how does the target look like? So, and that too, it shows you visually. Then let's look at how all of this actually helps you in terms of the ELT pipeline architecture. So you ingest data from a lot of sources. The raw data could be anything: BigQuery, cloud storage, sheets, databases, applications, file upload. You need to prepare that data before you can ingest that to any target. So from all of this data, maybe some data will go to BigQuery, some data will go to cloud storage. And that decision needs to be made before you invoke the execution engine, whether through Dataflow or BigQuery load, or even Dataprep in-memory engine. That decision is made based on how you understand that data, and that's where Dataprep fits in. It's that engine which enables you to make decision that which data should go where. And again, the analysis and ML, this is the standard part of operating on that data. And also, as part of any pipeline architecture, you have governance and automation capability, which is out of the box. So taking this whole holistic view of any ELT, extraction, load, and transform pipeline architecture, Dataprep sits between raw data and your execution engine, which will process that data. Now, that execution engine decision is made based on the characteristics of that data, and this is where Dataprep helps you. Now, let's look at Looker. Looker is termed as a modern BI tool. So traditionally, and let me talk through how it's different from traditional BI tools. So traditional BI tools, what they do is of course you can connect to your data warehouse, but often in between you have data marts or you have a semantic layer, because you want to reduce your load on the database, as well as you get the data in a prepared format. And this is how Tableau, Power BI, all of these tools work, is that you have a semantic layer, and then which is basically in the form of data marts. You connect to that data mart, and data mart, mostly those are views. So if data changes, they are automatically populated, and you get your data on the BI dashboards. Where Looker is different, that semantic layer is virtual. To put it in perspective, is Looker doesn't hold any data. What it does is it creates that semantic layer virtual, and anytime you are using Looker, it basically pulls that data from the underlying system. Now, that is only possible because the underlying database systems have matured over the year, and they have different ways data can be read much faster than it was possible before. And this is what Looker thrives upon. So what it is, it's an enterprise platform for business intelligence, data application, and embedded analytics. Embedded analytics is important. If you need a BI tool or virtualization tool, which can be embedded as part of your web app or mobile app or somewhere, and it renders the data really quickly, it's a really good option. It's an integrated end-to-end multi-cloud platform. It's multi-cloud platform because it can connect to Azure, it can connect to AWS, it can connect, literally it can connect to anywhere. And definitely on premises, but also the lot of SaaS applications. Now, Looker is actually based on LookML. So LookML is a language for describing dimensions, aggregates, calculations, and data relationships in a SQL database. So how does it? It's basically how does it work? If you try to understand that. So let's say there is a business user. He has some ideas and questions. He uses the Looker query builder, that this is how he wants to see the data, which is similar to in any BI application writing a query. But the difference here is that the Looker will generate the SQL based on what the business user has written. It will generate the SQL, and then it will query the data. It will send the result back to business user. Now, because it's virtual semantic layer, it interprets that into basically internally it's a text file where that structure is written, which is part of LookML project files. It's got data structure and business rules, specific way to write that, but everything is in text files, and that SQL is generated. What's the benefit? You are not limited by the semantic layer. You're not limited by what data is being pushed from analytical databases to the semantic layer, to the data mart, or whichever layer. It's basically creates the query, and every time it will go to the database. So you have complete flexibility in terms of the data elements that you want to fetch. How do you define LookML projects, which is basically a set of configuration files? Is basically it has models, views, and dashboards. What is a model? A model contains information about which tables to use and how they should be joined together. Here you typically define the model, its explores and its joins. So take a very simplistic approach. Model is just the tables. How do you join those tables in terms of keys and all of that? That is stored in model. So think of it from data modeling point of view. This is what typically data modeling, Irwin and all of that used to capture, is that the data model. So think of that data model in a textual format. So in a text file, you define all of those properties. Then comes view. A view contains information about how to access or calculate information from each table or across multiple joint tables. Here you will typically define the view, its dimensions, measures, its fields, and sets. So it just, from the model you are going to the next level. Dimensions, measures, and field sets. Then of course, the LookML dashboard, which basically brings all of that together and how the visualization look like. What's important to know is that under models, you have explores. So explore is often defined within a model file, but sometimes you need a separate explore, like for a derived table, or to extend or refine and explore across models. So this is basically when, again, giving a reference of data models, when it spans across different subject areas. So if you have ever looked at a data model in Irwin or something, we used to categorize tables in subject areas. So think of it, these are the different subject areas. A join lets you combine data from multiple views. So because it is all in text files, I think what's really important is that you can version control this in Git. It's not been possible with any of the other BI tools to version control that. It's just because of how the models are. There's a lot of things you need to store. But because it's a virtual semantic layer, you can version control using Git. And Looker itself takes care of giving you what you need for a particular dashboard. So you can model it at all of these levels and version control it at all of these levels. How you define models, how does your LookML project look like, and if you see what it's trying to do is like it's trying to create a construct of a project, and you can take that entire project and version control it on Git. Now, where does Looker fit in? On the left side, there's different ways we are getting data. There are different ways we transform data. So streaming data, pub sub data flow, it goes to BigQuery. Batches or long files, data files, cloud storage, data proc, and then it can go to other places. Web, you have a BigQuery streaming API, BigQuery, BigQuery data transfer, BigQuery ML, and Cloud SQL. So there are a lot of places where data is stored. How Looker works on it is that Looker doesn't store data. Looker always connects to these sources. So these are the sources where data is residing. Looker connects to these data to give you what you need. What it comes with a Looker UI where you can create interactive dashboards. You can also run ad hoc queries and all of that. As part of the platform, security, authentication, accelerators, APIs, Git version control is pretty standard. But the semantic data model. So if you think of, again, from let's say Tableau point of view or Power BI point of view, for a dashboard, what you will have is that different widgets and the queries those widgets run. Here, the same thing is captured in text files. And it's basically a virtual semantic data model, which is stored in GitHub or Git-based version control systems. Then apart from that, you get all of the developer SDKs and different ways for apps to actually interact with this. Then, as part of notification and everything, you can trigger different things, webhooks, emails, PDF, and all of that. Now, another thing to note is, apart from all of this, it can also connect to all of the SaaS systems or other cloud and on-premises system. Now, why is it Looker? Why does Looker work? Because it's pretty much doing the same thing as any other BI tool. Because it creates a virtual semantic layer. It's scalable, and it can go to any system. Most of the BI applications, they have some underlying database systems, and they cache that data, and a lot of times they temporarily hold that data. Or there's a very close connectivity between. They look at centralizing the data. I mean, any query, and that's how the concept of data warehousing came, collect all the data at one place, and the BI will only talk to that database. Because of there's a tightly integration required and the amount of traffic that is required. Now, Looker, because it's virtualized, it's literally virtualized. There is no semantic model. There are no facts, dimensions, and all of those kind of things. It's a virtual semantic layer. It's connecting to all of the sources, but it's not bringing any data. Only when the request comes, it's able to get all of that data. And most of these systems, they have API enabled access, so it's able to get that data pretty quickly. So it is a very important tool, but you have to understand the whole concept of virtual semantic models. And it's mainly being used for embedded analytics out of a web app or mobile apps because its response time is pretty good. Now, let's look at a service called Dataplex. Dataplex is it's a very new product recently announced, and I think it's still in review. So it's an intelligent data fabric that provides you a way to centrally manage, monitor, and govern data across data lakes, data warehouse, data marts, and make this data securely accessible to a variety of analytics and data science tools. So why Google created Dataplex is that we always have this problem. Data sits everywhere. There are a lot of databases. There are a lot of data warehouses. Sometimes there are department-based data lakes, data marts. Now, when you need to access that data, you end up following specific chain of roles, chain of authorization. Dataplex is an effort to create a data fabric. So you know the roles. I mean, you know which data can be accessed by who. So think of it as an achieving a freedom of choice, right, to store data whenever you want for the right price, performance, and choose the best analytics tools for the job. Now, if we need to put it in a simplified way, so having a fabric across all of your data storage systems, so data warehouses, data lakes, it could be anywhere, and data marts, and have a unified data management in terms of metadata, lifecycle, governance, security, that who can access this data. That's where Dataplex is looking to solve that problem. Now, let's take an example, right? When you write Parquet file, taking an example of a Parquet file to a Google Cloud Storage bucket, Dataplex will automatically extract metadata for these files, detect a tabular schema, including Hive style partitions. It will run data quality checks and make this data queryable in BigQuery as an external table and from any open source or partner application with the same consistent security and access policy you define at the logical data layer. So trying to make it simple is when especially in case of data lakes and is that you store it across landing zones, structured zones, refined zones, different storage, different people have different access. But if there was a unified way that the access is assigned, the access which should be assigned on a data element, if it can be governed centrally, then it will be much easier. So you have structured, semi-structured, and unstructured data. A tool can automatically extract the metadata and classification across any of your data analytical solutions. It will apply data validation and quality check. So if date of birth is coming, you want to store it in a certain format, so MMDD YYY or YYYY MMDD. Now You want that same format to be applied to all date of birth across, doesn't matter who's holding that data. Think about this solution then. And then it will be no matter where the data comes from, if it is within the tenant or tenancy of Dataplex, it will apply the same validation and quality check to all data of birth coming from any system into these analytical solutions. Then you can, of course, use data catalog for searching and discovering that data, and then unified metadata across BigQuery and open source. This is what it gives you, which helps you with your data science, which helps you with analytics. So your BI analyst and your machine learning analyst, they are not complaining that they don't know which version is true. So this is where Dataplex is trying to make an impact, that to have a uniform governance across data that sits across multiple analytical solutions. Another interesting service which has recently been announced is Analytics Hub. It's supposed to be available in preview in Q3. So this is meant to solve the problem of sharing and exchanging data, especially with other organizations, because that's a really big problem, right? As part of analytical strategy, it depends on how much data you can share with other organizations, other parties, or sometimes the businesses which help you grow. But it's hamstrung by either data is unreliable or the process is too complicated, and it just gets more tougher with security threats and privacy regulations which are on the rise. With Analytics Hub, what you get is a rich data ecosystem by publishing and subscribing to analytics ready datasets. So if I look at this Analytics Hub, it's basically defining what's private data, what's public data, what's commercial data, what's just Google data. Then you have a publisher project. So this project publishes data into Analytics Hub. Then the subscriber can subscribe to this data from Analytics Hub. So if you have 10 publishers, let's say 100 subscribers, there's not point-to-point interaction between all of these publishers and subscribers. Analytics Hubs becomes that exchange server where publishers can push the data, not worry about who wants it. Subscribers can get it from there, depending upon what category of that data it is, without worrying about interacting with publishers or reaching out to publishers. Because you can define your data in terms of private, public, commercial, or different categories, you can control and monitor how that data is being used, because data is shared in one place. It's a self-service way to access valuable and trusted data assets, including data provided by Google. And also, I think the biggest use case of this will be the data monetization. Data monetization is all about having that control that the person who's going to use it, you have a return in value. Now, because it gives a unified place where the subscribed or approved parties can use that data, it makes it a kind of a data marketplace, if you think it in that regard. It's a marketplace for data assets. And that way, once you prepare that data and you put it into the marketplace, it automatically becomes a monetizing asset. So this is something coming up, but I wanted to bring it up because it's a very common problem in terms of exchange of data, mainly because of privacy and security and regulations. So that's why I wanted to talk about this one. Next one, let's summarize everything and let's look at different use cases of data analytics and which are the Google services which help you with that. Data-aware modernization. BigQuery is the de facto choice for that. It's the only serverless analytical database that's available in the industry. BigQuery, along with its machine learning and geospatial analysis, it helps you modernize your data warehouse. Data lake modernization. So typically data lakes, either you come from Hadoop based systems or any of the system where you are worrying about the cluster, you are worrying about what data you should store, you are worrying about where you should store that data. Google provides you a variety of options. BigQuery in terms of the queryable data, Dataprep, Hadoop cluster, completely fully managed wherever you need, Spark, Flink, or any of the 30 plus open source projects to process your data while it's completely managed. Dataprep is the option. Cloud storage for any archival long-term storage, cloud storage is the option. Stream analytics. Again, data is streaming through PubSub as a messaging service. Data flows integration with PubSub gives you a proper watermarking, your proper control on the delivery of your messages, and then each one of these services can feed data directly into BigQuery. So before, if you have had experience, we used to have Lambda technologies, Lambda framework or Kappa framework to process streaming data and batch data separately, and have at some point of time have a backdoor reconciliation of that data. With these technologies, you can ingest stream and batch data at the same time to the same destination. Data integration, Cloud Data Fusion for a lot of massive data loads. Data flow, again, a completely serverless way to do data integration. PubSub, very good as a broker system. Data security and governance, data catalog to catalog the data, figure out the business and technical metadata. Cloud DLP to keep a check on sensitive data. And all of this integration with Cloud IAM, which lets you define the owners, editors, and readers of any data. Workflow orchestration, Cloud Composer based on Apache Airflow is a really good orchestrator. You can build end-to-end applications. You can spin up servers which will run your integration pipelines. Cloud Functions, again, serverless, single purpose events that you can trigger from Cloud Functions. Marketing analytics, Google Marketing Platform, Data Studio, and BigQuery DTS, data transfer services, which can directly transfer data from a lot of SaaS applications into BigQuery. Then at the end, business intelligence. Business intelligence has been there. It will always be there. The terminologies will change. Names will change. Business intelligence will get empowered by embedded analytics, data virtualization, visual analytics, but you need a tool to broker those shiny data dashboards. Looker, as we talked about, virtual semantic layer for embedded analytics. BigQuery BI engine built on top of BigQuery, which BI tools can connect to get the data faster. Connected sheets from Google Sheets, you can connect to BigQuery and work on billions of rows from a sheet. Data Studio, very simple, intuitive BI tool which can connect to most of the systems, and often used with BigQuery for creating dashboards on top of BigQuery. So I hope this was useful. Data analytics services keep growing because that's the major focus of most of the industry, to understand the data, how to move that data, how to act on that data, how to govern that data, and how to get insights out of that data. So I hope this section was useful. Thank you.